I'm Anil Kumar. Welcome to my series on distance, speed, and time. We'll see how to describe a given graph on distance and time. We have an example here. This is going to be your test question. And I'll take up two examples where I'll actually provide you complete solution. However, this one I'll explain you the concepts. And at the end of the video, you're supposed to answer this particular question. I have another video to follow up where I will provide you a solution for the question right in front of us, along with some other distance time graph word problems. So I hope that will be very interesting, and that is going to help you to gain confidence in answering such questions. So the very first question is, how do we read a distance time graph like one shown here? We have shown time on the horizontal axis. Time within brackets S means time is in seconds. The vertical axis we have used distance D, and the units mentioned here are meters. We have written distance in meters versus time in seconds. Very small print, may be difficult for you to read now. Now this bold line which is connected shows the distance of a person or any object with time. Remember, time moves on, and we have different positions where the person is. Now this is always considered to be the origin, right? Now when we are trying to describe this, there are some parameters which you should keep in mind. One is, from distance and time we can find speed, right? So what relates distance, speed and time is this little triangle, which many of you know. So basically, let me just remind you of the relation. So distance, speed and time are related with the relation that distance traveled is speed times time, right? Faster you run, more distance you covered. For more time you run at the constant speed, more distance you covered. So distance is proportional to both speed and time, correct? So that gives you a relation that distance is speed times time, right? Now most of the time when you are given distance and time, what is missing? Well, the speed is missing, right? So one of the important things to always figure out is the speed. Now speed you could find in different intervals. So what will the speed be? A straight line shows a constant speed, right? So this is a straight line shows a constant speed. Let me write down constant speed for straight line. Okay, remember that, right? So all these straight lines means it is a constant speed. Now speed is constant between two intervals. Here we have mentioned A to B, B to C, C to D, D to E, right? Those are the different speeds. So you have to calculate speed over a particular interval. Let us say speed over interval AB, right? So the first leg of this particular graph. Then how do you find speed? Well, what you need to do is read the change in time along with change in distance. Now here the distance decreased by, this is in meters. From 6 it came down to 4, correct? So the change is basically 4 minus 6, right? That is the change of 2 meters, and time taken was also 2 seconds. So 2 minus 1. So that is what it is. So it is change in distance over change in time. So let me write down. So speed basically you learned here is distance over change in time. So in our case, what we get here is minus 2 over 1, which is minus 2 meters per second. So change in distance. Now distance here is in meters and time is in seconds, and therefore the units will be meters per second. Now in case of speed, minus only shows you that it is approaching, right? So remember this, minus means, negative means approaching. Is that clear, right? So if you get positive, as it is going to be from D to E, it will be going away, right? So it is coming, right? Or back or return. So those are the different terms which could be used. However, when you write speed, you have to write always a positive value. So you will write absolute value. This means always report positive value. Do you understand? These bars when I'm making here, it means that write down answer as positive value. So in this particular case, we will describe the speed as that in the first second, in the first 2 seconds, first 2 seconds, the person is approaching at the speed of 2 meters per second. Do you see? I have dropped that minus sign and I've used the word approaching. You get the idea. So whenever we say speed, we have to think about this as a number, which is always a positive number. Negative only says it is coming closer. The distance is decreasing with time. Correct? You can see when the graph goes downwards, distance is decreasing. To start with, the person was at 6. And now after 2 seconds, person is at 4. So the distance has decreased, right? So we have discussed one very important parameter which you should always be writing for each and every leg. Correct? So what you notice here that from A to B and B to C, the distance is decreasing, speed you will get negative, write as positive. What happens from C to D? Well, if the distance is not changing, it means what? This means what? This means he is not walking, right? It is at a point, standing. Do you see? There is no change in position. So when you describe, you could describe this position as standing. You get the idea, right? So that is how you have to use different words to explain the given situation. That's very important, correct? Now, from D to E, as you can see, it is increasing, right? So this portion, it is going away. We say distance is increasing, right? So we say distance is increasing. Do you see that portion? So in this, from D to A, it is going away. So in every leg here, you have to find the speed and use these words, whether the person is approaching, going away, or at a point, standing. So that is regarding the speed, which you have to calculate from the graph. You get an idea, right? So that is the calculation required whenever you have a graph. Now, what are the things which you can straight away read? So let's now say, what can you read from graph? Now, this is easier stuff. That was calculate, right? Okay, so you have to calculate speed, right? Because it only gives you distance and time. Now, out of the things which you can read, important things to consider is always the starting point, right? Starts at. This is a very important, right? So in this case, the position starts at what? He begins or start, you can use start or the word begins. Right? These two words could be always used for the starting point. So in this case, starts at or when it was 6 meters away, right? So at a distance of 6 meters in this particular situation. You get the point. So when you are reading the data, you can always read this kind of information. First, most critical is from where it all starts, right? Similarly, the ending part is very important. Ends at what time? Then you can also see the duration, total duration, right? So you can see duration of each leg, correct? So those are the other things which you could see. Now, There are some other important things which you may have to calculate, and that is, let me write like this, which is kind of common. You can read from the graph also, you may have to calculate also. So total distance covered, total distance. Sometimes we also say net displacement. Now when I say displacement, it means what? How are distance and displacement different? Let's think about that also. Now let me answer. Here itself, we have a position here where a person starts from 6 meters away and actually ends also 6 meters away. So the distance is, the person comes up to 1 meter. So this is traveling 5 meters in this direction and then going away 5 meters, right? So the total distance is basically 5 meters plus 5 meters, which is 10 meters. So the distance traveled by the person is 10 meters. However, what is the displacement? Well, the displacement basically is 0 meters. Why? Because the person started when he or she was 6 meters away and ended up at the same position. Do you see that? Time flies away. Think about the person coming like this and going back to the same position. So as far as distance is concerned, the person walked 5 meters and went back 5 meters. Total distance was 10 meters. Displacement 0. No change in position. Do you understand? So that is how these two terms are very different, correct? So these you could actually read directly from here, or you could calculate also. But I'll put this under the heading of reading is intelligent reading, correct? So these are important parameters which you should always mention when you describe a particular graph. So I hope that is clear. Now if there is any difficulty, you can always contact me, send your inquiries to this email. Now we'll actually take two examples in which we'll totally describe the distance time graph, and we'll also create a graph from the given situation. I hope that sounds interesting. Okay. Now here is our first example. We'll describe the situation and write important characteristics. The graph is right before you. On the horizontal axis, we have time in seconds. On the vertical axis, we have distance in meters. The question is, explain the distance versus time graph and determine total distance traveled, average speed, maximum speed, displacement, interval for object moving away. So in such questions, it is always better to answer these questions and then explain the distance versus time graph. So it becomes easier for us to explain since we'll have some values which we can use in our explanation. So I hope that point is absolutely clear, right? So we'll go kind of backwards, and then later we'll see how to describe the situation. Is that okay? So we should begin from these items, correct? So let's start. Total distance traveled. So a person here starts from this position, goes away, that is going away, and it moves up to this place, right? So what is this position? So the graph shows that this is 2 units each, 2 meters. So this position is 14 meters away from 0. So you can see that the person goes 14 units up, that is 14 meters up, and then returns back 14 meters. So the total distance is 14 plus 14, which is 28 meters. Is that clear? So the first answer is that the total distance traveled here is 28 meters. Second question. Second question is average speed. Now we have not mentioned which area, right? So when we say average speed, it will be for the total duration. You can see that the distance traveled is how much? Distance is 28 meters and time is 4 seconds. So average speed is total distance over total time, right? So in our case, how much is it? Total distance is 28, we just found, right? So we'll just write 28, and the total time here is 4. So dividing 28, which is in meters, by 4, which is in seconds, we get the average speed of 7 meters per second. So I'll write here 7 meters per second. Is that clear? 28 divided by 4. Perfect. So we get our answer, which is here. Let me write down here. So average speed is 28 divided by 4, which is 7 meters per second. Is that clear? Okay. Next, maximum speed. Now maximum speed is, you have to see which portion of the graph is steeper, right? So we're looking for a steeper graph. So this seems to be maximum speed, right? So you come to know from the steepness of a graph what should be the maximum speed. You can calculate with distance and time relation. So make a triangle here, right? Now speed is what? So we know that triangle. Let me again sketch this for you. Okay. So we'll again sketch our triangle here, which is distance, speed and time. We want maximum speed. Maximum speed is change in distance, and distance is 14, right? It goes from here to here. That means change is 14 meters, though negative, right? So maximum speed will be minus 14 divided by time taken is 1 second. 1 second. This is in meters, this is in seconds, and what do we get? We get 14 meters per second, right? So we get 14 meters per second. Always we'll say positive. It may be negative. It means approaching, right? So the negative here means what? Approaching or returning, right? So maximum speed will be, in our case, 14 meters per second, right? Negative means coming back, right? Or returning. Does it make sense to you? Here, what is the speed? That 14 meters is covered in 2 seconds. It is half of 14, which is 7. Do you see that? Okay. Now, the next question here is to find the displacement. So displacement basically is change in position. Start to finish position. In our case, it is 0. Since it started from 0 and ended also at 0, right? So displacement is 0 for us. Is that clear? 0 meters you can write. Okay, no problem. The last question here is interval for object moving away. So away means the distance is increasing. Okay, so whenever we say away, away means what? Away means distance increasing. So in our case, the object is moving away in the first 2 seconds, right? So it is in the first 2 seconds. Is that clear to you? Correct? So that is how we could answer all our questions. Now, let us try to describe this situation, right? We have seen that we have a speed of 7 meters per second and 14 meters per second. Normal walking speed is kind of around 3, 4, 5 meters per second. When it is more than that, we could say jogging, right? So that is one thing which we learned here, right? So basically when we walk, it is up to 5 meters per second, right? And jog could be, let's say, 5 to 8 meters per second, and run could be, let's say, 10 meters per second plus, right? You get my point. So we could actually divide so that we could easily describe what the person is doing, correct? So in our case, while describing, we can say that the person jogs for first 2 seconds, right? So we can say that person jogs for 2 seconds at a constant speed of 7 meters per second, right? He's covered 14 meters in 2 seconds. Do you understand? Person jogs for 2 seconds at a constant speed of 7 meters per second and moves 14 meters away, right? So in this statement, we have actually described the movement from the starting point, let's call this as A to B. Do you see that? A to B. Now we'll describe from B to C and then from B to D. Does it make sense to you? So if you go like this, you are giving a very good description, and that's the whole idea, correct? Okay, so this is our first statement. Now B to C, what do you observe? There is no change in position, right? That means for 1 second, then you could say he or she, right, rests for 1 second. Do you see that? So for 1 second, from 2 to 3, there is no change in position. So the person is just resting there at this point. And then what? The third is from C to D. So what do you think is happening at this point? You can say that the person returns running at a speed of 14 meters per second. Does it make sense to you? So that is how you could describe the whole situation. Is that okay? Now, in the description, it is also very good if you could add some more information, right? So what should you add? You should add what you calculated, right? After all, that is a very important. So you can say that the total distance traveled was, add all this. I will say add all this, right? Total distance traveled was 28 meters. The average speed was 7 meters per second. And the maximum speed was 14 meters per second. And that was while he was returning back. The net displacement was 0, right? So you add all those points which you calculated to finish it off. Does it make sense to you? If you do that, that is covering up all the points. So I hope that makes sense, correct? Now, let's take another example where the description will be provided and you will be in a position to sketch the graph. Hope that sounds good. Okay, now we have description and we need to sketch the distance time graph. The question for you is, draw a graph based on the description provided. A person begins 40 meters from the start. She runs back 14 meters in 0.8 seconds at a speed of 17.5 meters per second. She slows down and runs back another 8 meters in 1.6 seconds at a speed of 5 meters per second. She runs forward 16 meters in 1.2 seconds at a speed of 13.3 meters per second. She stops for 0.4 seconds. That is for you. So have a graph paper kind of shown here and try to sketch this particular graph, right? Here is how I will kind of do it. So it says a person begins 40 meters from the start. So that is 40 meters, right? So 0 time. Time starts now, right? And then she runs back 14 meters in 0.8 seconds. So this scale, from here, we have to come down to 14 meters, right? So this is 10 meters, and then each unit here is 2, so that becomes 14. And this 14 meters is covered in 8 seconds, right? So that is the approximate position. The lines are not all that clear, right? So this is 1 for you. So point 8 will be 2 units before 1. So kind of here. Do you see that? So this is the position at 8 seconds, correct? 0.8. Is that okay? And the position here will be what? We have to reduce by 14, right? So you could do your calculation also. You do 40 minus 14 to get to the net value, which will be how much? Which will be 26, right? So that is your value, 26. Is that clear? So you get your point, which is right there. Now speed is already calculated. You need not bother about the speed. Okay. She slows. Sometimes they will not give you time. They will give you the speed directly, right? So you have to now work out. Okay. Now she slows down and run back another. Back means returning, right? So it's coming downwards. So first leg we're done, which is this position. Is that clear to you? Okay. Second. She slows down, that means it is not going to be that steep, less steep, and runs back another 8 meters in 1.6 seconds at some speed given to you. When they give you meters and seconds, no need to bother about speed, okay? That's kind of simpler for you, right? So 8 meters, you have to reduce 8 meters. We know from 26 to 20 will be 6 meters and then 2 more. You get the idea? So that is how you can get 8 meters. Otherwise, from 26, you take away 8. We are running back, so we have to take away, correct? Does it make sense to you? So we get what? We get 18. So at 18, says she slows down and runs back another 8 meters in 1.6 seconds. So this is 0.2, right? And then 0.2, this is 1.2, but we want to go 1.6 seconds, right? So 0.2, or you could do like this, plus 1.6 seconds. Add them up. What do you get? You get 14, 2.4. So add 2.4, which will be kind of like here, right? And here we have 18. So it is kind of like this. These lines are not very clear. So I'm just showing you with dotted lines. So the person comes like this. She will be right there. You get the idea, right? So that is going to be the position, which position coordinates will be 2.4 and 18. Does it make sense to you? Now, she runs forward 16 meters in 1.2 seconds. Now, you are at 18. If you're going forward, you will go like this, right? She runs forward 16 meters. So now we'll add 16 to this and get our new point. 8 plus 16 is 14, 4, 1. And 1, 2, 3, 34. So you land at 34, right? In 1.2 seconds. So in time, we'll add 1.2. So we'll land up at 3.6. Does it make sense to you? So 3, this is 4, this is 5, 3.6 is kind of like this, right? And 34, 30, and then 1, 2, and 4, correct? Do you see that point? So that becomes your point, which will be on time, it will be 3.6, and on distance, it is going to be 34, correct? So the final will be this position. Does it make sense? Now, what happens? She stops for 0.4 seconds. So we'll go for 0.4 seconds. That means 2 units, right? So this will be the position. And here will be, when you add 0.4, you get 4 and 34. The distance is not changing. Do you understand? That is how you are going to sketch the distance time graph. So I hope the way it has been done, that is very simple and easy way to do it. If you try to do them separately, it is going to be very difficult, right? So again and again, you need not do. It is a constant movement, add and subtract, like you do with integers, correct? Same with time. Keep on adding. Time goes in one direction. In the first 2.4 seconds, she is actually approaching, right? And then she returns, the distance increases. So I hope all this makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. Thank you.